Good morning. So this lecture is of the topic Basics of Radiation. Before going to the subject, let us pray for the soon recovery of the COVID patients. Also, we shall give respect to the doctors, nurses, அப்புறம் போலீஸ் டிபார்ட்மெண்ட்ஸ், முக்கியமாக வந்துட்டு தூய்மை பணியாளர்கள், அவர்களுடைய சேவை தான் வந்து ரொம்ப இந்த டயத்தில் வந்து ரொம்ப முக்கியமாக தேவைப்படுறவங்க. ஸோ விரைவில் வந்து அவங்க எல்லாரும் இந்த கொரோனாவை விரட்டிட்டு அவங்களோட நார்மல் லைஃபுக்கு திரும்புறதுக்கு இறைவனை பிரார்த்திப்போம். ஸோ அரசுக்கு வந்து இந்த விஷயத்தில் நம்ம முழு ஒத்துழைப்பு கொடுப்போம். அதே மாதிரி சுகாதாரத்துறை அவர்களுடைய பணிக்கும் முக்கியத்துவம் கொடுப்போம். ஸோ நம்மளால் எப்படி இதை வந்து செய்ய முடியும் அப்படின்னா, we have to maintain discipline by staying in home. ஸோ இதனால் வந்து நம்மளையும் காப்பாற்றிக்க முடியும் இந்த வைரஸ் தொற்றுலேருந்து. அடுத்து நம்ம குடும்பத்தாரையும் காப்பாற்றிக்க முடியும். அதோட இந்த சமூகத்தையும் வந்து நம்ம காப்பாற்ற முடியும். இந்த வீடியோவில் நம்ம பார்க்க போகிறது ரேடியேஷன் பேசிக் கான்செப்ட்ஸ். நெக்ஸ்ட்டு அப்சார்ப்ஷன், ரிஃப்ளெக்ஷன் அண்ட் டிரான்ஸ்மிட்டன்ஸ் ஆஃப் ரேடியேஷன், அந்த கான்செப்ட்ஸ். அப்புறம் அப்சார்பிவிட்டினா என்னென்னு பார்ப்போம், ரிஃப்ளெக்டிவிட்டினா என்னென்னு பார்ப்போம், அண்டு டிரான்ஸ்மிட்டிவிட்டி அப்படின்னா என்னென்னு பார்ப்போம். அதுக்கப்புறம் வந்து பிளாக் பாடினா என்ன, நெக்ஸ்ட்டு கிரே பாடினா என்ன, அப்புறம் ஒபேக் பாடினா என்ன, அப்புறம் டயாதெர்மஸ் பாடி அப்படின்னா என்ன, தட் இஸ் டிரான்ஸ்பரண்ட் பாடி அப்படின்னா என்ன. ஸோ இதெல்லாம் பார்க்க போகிறோம். நெக்ஸ்ட்டு பிளாக் பாடி கான்செப்ட் என்னன்னு பார்ப்போம். அதுக்கப்புறம் வந்துட்டு கிரே பாடி கான்செப்ட். ஸோ இதுதான் இந்த டோட்டல் லெக்சரோட கண்டென்ட். ஸோ ஃபர்ஸ்ட் let us see what is radiation. See, we have three modes of heat transfer. One is conduction, another one is convection, and third one is the radiation. So our focus is fully on radiation heat transfer. So how radiation takes place? So when a body is at very high temperature, it emits heat or thermal energy in the form of electromagnetic waves. In the form of electromagnetic waves. Let us take this as an object or a body which is at a temperature T. So it emits or radiates energy in the form of electromagnetic waves. So these are all electromagnetic waves. So best example for this is the solar radiation. So sun is let us consider sun is an object which is at very high temperature and it emits heat energy, as we all know, and this reaches the earth. So it has to travel a long path. Even the heat rays travel in the vacuum also. So for radiation heat transfer, we don't need any intervening medium for the heat to be transferred. Okay. Now let us see what is the amount of heat transfer or heat transfer rate. So this is our dq by dt is proportional to surface area A and the fourth power of its absolute temperature. So dq by dt is proportional to surface area and the absolute temperature. It depends upon the absolute temperature. So now I am removing this proportionality by introducing a constant sigma, which is Stephen Boltzmann constant. So another factor I am introducing is the emissivity, E. So sigma is Stephen Boltzmann constant. Its value is 5.67 into 10 power minus 8 watts per meter square Kelvin power 4. So this is the heat transfer rate. So the emissivity. So emissivity, what is emissivity? It is the property of the object. It varies from 0 to 1. For materials having high emitting power is in the range of 1, whereas material having a low emissive power is equal to 0. Now let us discuss about the reflection, absorption and transmittance of radiation. Now let us consider an object or a body over which incident heat radiation falls. Let Qi be the amount of or quantity of heat incident on the surface. So after incidence, some amount of heat or some quantity of heat is getting reflected back from the surface. Let it be Qr. Some amount of energy is absorbed by the body, let it be Qa, and some amount of heat energy is transmitted through this body, let it be Qp. So the incident radiation Qi, or the quantity of heat incident on the body, is equal to sum of the three ones, Qa plus Qr plus Qp. Now I am dividing both sides by Qi, so we get 1 is equal to Qa by Qi plus Qr by Qi plus Qt by Qi. So this ratio Qa by Qi, quantity of heat absorbed by the body to the quantity of heat incident on the body, is called as absorptivity. Alpha, plus this ratio Qr divided by Qi is called as reflectivity, rho, plus this ratio Qt by Qi, quantity of heat transmitted to the quantity of heat incident. This ratio is called as transmittivity and it be tau. So we have alpha plus rho plus tau is equal to 1. So alpha is called as absorptivity, rho reflectivity, tau transmittivity. So now I can define absorptivity as the ratio of quantity of heat energy absorbed by the body to the quantity of heat energy incident on the body. Similarly, the reflectivity as the ratio of quantity of heat energy reflected by the body to the quantity of heat energy incident on the body. Similarly, transmittivity, tau, it is the ratio of quantity of heat energy transmitted from the body to the quantity of heat energy incident on the body. So sum of these three, that is absorptivity, reflectivity and transmittivity, is equal to 1. So for a perfect black body, what is a black body? Perfect black body. So black body is a body which absorbs all heat energy falling on it. All heat energy falling on it. So it's absorbed. Then QA is equal to QI. Therefore, alpha value is now become 1. So if it is 1, again these two values now become 0. So 1 plus 0 is equal to 1 if alpha is equal to 1. So that is, all the heat energy incident on the body is getting absorbed by the body. So it is a perfect black body. We can say it is a perfect black body. One absorptivity value is 1. Similarly, if rho is equal to 1, now let us take rho is equal to 1. When it becomes 1? If alpha is equal to tau is equal to 0. That means reflectivity value is 1. That is QR by QI is equal to 1. So all the heat energy incident on the body is getting reflected. None of the energy is absorbed by the body, and also none of the energy is transmitted from the body. Therefore, the heat energy that falls on the body is completely reflected. Then only the rho value is become 1. Now, this body whose value is 1, that means all the heat energy incident is getting reflected, is called as white body. If alpha is equal to 1, it is called as black body. If rho is equal to 1, it is called as white body. So white body is a body which reflects all the heat energy falling on it. Now let us come to this transmittivity. If tau is equal to 1, that means transmittivity value is equal to 1. Then alpha is equal to 0 and rho is equal to 0. That is, alpha is equal to 0 and rho is equal to 0. That means all the heat energy that is incident on the body is getting transmitted. So these type of bodies are called as transparent bodies. Are called as transparent or diathermous body. That is, transparent bodies are a body which transmitted all the heat energy falling on it. And other one is opaque body. For opaque body, the tau value must be 0. For opaque bodies, tau value must be 0 for opaque bodies. That means it has certain absorptivity value. Similarly, it has certain reflectivity value. So alpha plus rho is equal to 1. Okay. Now let us discuss about the black body concept. As we have already discussed about the black body, so black body is an ideal body which absorbs all the heat energy falling on it. Its absorptivity value is 1. So how to make a model? Now let us have a hollow metal a small hole at this point. Now heat rays falling on this body, and through this hole, and incident ray is entering like this. Once it strikes the inner surface of the body, it gets reflected like this. So during this incident, some amount of heat energy is absorbed and the remaining is reflected, and this body is perfectly insulated so that no heat energy is escaped or transmitted from this body. So this ray, heat ray, undergo multiple reflections inside the sphere, inside the metal sphere, I can say, metal hollow sphere, I can say like this. So for every hitting of the ray inside the hollow sphere, some portion of the heat energy is absorbed. So it undergoes a multiple reflection like this, and finally it escapes through this small hole. So each and every time when hit inside the inner face, it loses some energy to the body. So the body gained all the heat energy. So this is the black body concept. Now let us see grey body concept. What is a grey body? So grey body, if a body absorbs a definite percentage of incident radiation irrespective of the wavelength, then it is called as a grey body. So a grey body is a body that absorbs a definite percentage of heat incident on it irrespective of the wavelength, of the incident rays. So now let us compare the grey body emissive power with the black body emissive power. So in the y-axis, let us take emissive power, monochromatic emissive power, and in the x-axis let us take wavelength. For a perfect black body, the curve is like this. That means as the wavelength increases from here to a certain length in the x-axis, the emissive power is also increased and reaches a maximum at this point. Again it falls down. So this is for a black body. Similarly, for in the same range, the peak value is somewhat below this black body for a grey body. So the grey body is like this, the curve is like this. So the emissive power reaches only to this point. So a definite portion of heat energy is absorbed, definite percentage. But the emissive power is lesser than the emissive power of a black body. This curve is for grey body. Now let us discuss about what is the emissive power. It is denoted by the letter E. So emissive power is nothing but the amount of heat energy emitted per unit time, per unit area. So E is equal to sigma T power 4. So we have already discussed about the heat transfer rate in the previous session. Here A becomes 1 and similarly T is also 1. So E is equal to sigma T power 4, where T is the absolute temperature of the body. Its unit is watts per meter square. So this video is meant only for the final year diploma refrigeration and air conditioning students having the subject design of air conditioning, refrigeration and air conditioning. So here we have discussed about the radiation concepts, what is meant by radiation, next absorption, reflection and transmittance concepts, then black body concepts, grey body concepts, etc. So any clarifications regarding this radiation, the students can contact me at any time. So suggestions, comments are welcome. Now I am going to say some important board exam questions in this unit. First question is, define radiation. What is meant by radiation? Second one is Stephen Boltzmann law. You have already studied the Stephen Boltzmann law in the first unit itself. So once again I am repeating the answer for this. So the emissive power of a body is directly proportional to the fourth power of its absolute temperature. Second question is Stephen Boltzmann law. That is, emissive power of a body is proportional to fourth power of the absolute temperature or equal to sigma T power 4, where sigma is the Stephen Boltzmann constant, whose value is 5.67 into 10 power minus 8 watts per meter square Kelvin power 4. And another question is, important question is, define absorptivity. Define transmittivity. Define reflectivity. What is meant by black body? What is meant by grey body? What is meant by opaque body? What is meant by transparent bodies? So these are all 2 more questions. One important 10 more question is like this: explain in detail the transmittance, absorption and the reflection of radiation. Another 10 more question is, explain about the black body concept and the grey body concept. Thank you very much. Thank you.